Hi students, welcome to my course on ANSYS Structural Engineering. Today we will discuss what is workbench, ANSYS workbench. In order to start ANSYS, you will press this Windows 10 option and just type workbench. And before starting the workbench, I want to explain something, because when you type ANSYS here, you can see a lot of things, ANSYS I Speak and ANSYS client. And if you go to ANSYS folder, you can see several softwares. This is actually academic research version, and this consists of a lot of other softwares. The reason is that during the implementation of the ANSYS, or after starting the ANSYS company, they purchased a lot of other things, other softwares. One of the example is Fluent. Fluent, it's actually a very good software for CFD simulations. They purchased it. And similarly, they purchased LS Dyna portions and Autodyne. So many softwares they purchased, and all these softwares are included here. So that's the confusion when you open this one. If you go to ANSYS folder, you can see a lot of softwares. In order to combine these softwares into analysis, they created something called as a workbench. So in workbench, you can drag these softwares, that is individual software interfaces, and you can connect that with the ANSYS interface. So that's why we are going to learn workbench here. So type workbench. So my version is workbench 2021 R2. This is the workbench interface. So top side, so you can see file menu, file view, tools, units, extensions, jobs, help, all those things you can see. These are the shortcuts for the file menu. And one more, when you go down, you can see import, reconnect, refresh project, update project. Because there is no project, that's why it is disabled. If you start any project, it will be activated. And one more important thing, it is ACT start page, ANSYS customization toolkit, where you can create your own tools to do the analysis or to incorporate additional capability of ANSYS software. And again, just below the ACT start page toolbox, you can see toolbox. It consists of 5 options: analysis systems, component systems, custom systems, design, exploration, ACT. So analysis systems is actually, you can consider it as a tailored system, so that is predefined system. Just like a ready-made cloth, it's already stitched, so you can use it right away. So similar to that condition, these systems are created for particular analysis. For example, if you take static structural, you can see all the informations or all the modules needed for static structural. It is assembled in order. So this one represents engineering data to give the material properties, to geometry to create the geometry model. You need to do the discretization, that is meshing. So for that, model is used, and setup is to give the boundary conditions, solution for solve the problem. Then results, because after solving you will get a bunch of numbers, so you need to convert that into a visually readable or a understandable format. That is what is called as a post processor. The result module is used for post processing the solution results. So this is actually made to do a static structural analysis. If we take another analysis, for example a CFD analysis, you can see there are some portions missing. For example, engineering data. Why? Because we will give the engineering properties or the properties of the fluids inside the Fluent module. So that's why engineering data is not provided, and the element selection also will be different. Because most of the time students will ask us, sir, how can I give my custom element? While selecting the type of analysis or type of analysis systems, the element selection is already completed. But if you want to change it, you can change it with the help of commands, APDL commands. You can change the element. But when you are selecting, an optimum element will be selected by ANSYS, so there won't be any options to change the element. Okay. Similarly, in fluid flow also, when you select the fluid flow, the element selected will be by default, it's a CFD element or a fluid element. So this is what is called as analysis systems. It's already defined systems to do the particular analysis. And component systems, it's as the name says, it's the components of the analysis systems, or you can say the components are combined together to get these analysis systems. So you can see geometry and model, everything you can see here. So if you want to control it separately, for example, you want to control the geometry separately, you can create this geometry, and you want to couple it with a structural analysis, you can give a direct connection to the structural analysis. So these two geometries are connected. Whenever there is a change in this geometry, it will be automatically reflected in this session. Then the next one, custom systems. Suppose you want to create the system as a custom system. For example, you need a static structural, you need a fluid flow, and you need another static structural element, and you, in your entire analysis, you are going to repeat it for 10 to 20 times. So every time you must create the static structural, fluid flow and these connections. You don't need to do that, because you can create a custom system. If you right click and add to custom, if you give add to custom, you can give the name. So I'm giving it as a test system, and I'm going to delete all these things. Okay, so my test system, that is the name of the system, analysis system, which I gave name. So it's appearing here. If I double click this test, the previously created things, everything is back. So you don't need to recreate it again. If I click the test system, again the similar thing repeated. So you don't need to do everything, because it's a tedious process. Every time you need to drag the static structural, drag the fluid flow, drag the geometry, drag the static structural. It's very difficult. But if you create a custom system, you can create it, and these systems are actually multi-physics systems. It is coupled with a fluid flow and a structural analysis. So these are the systems which ANSYS provides. ANSYS has already created some of the systems for your easiness. So either you can utilize these systems, or you can create your own custom systems. Anyway, I'm going to delete the system. Okay. Then design exploration, that is something related to optimization. That is, suppose you want to optimize some of the parameters. If you take the case of blade, you want to optimize the material, you want to optimize the diameter. So after the base analysis, you can go for some optimization technique, like a surface response optimization or direct optimization. So all these options you can utilize to do the optimization. And the last one, ACT, where you can create a customized workflow. Basically, customization means you can edit the options available in ANSYS in order to create new thing, or in order to automate the process. That's why ACT is used. Okay, thank you. Next, we will discuss about file menu. File menu consists of conventional options like new, open, save as. All these things are there. Apart from these options, so they provided an archive option. Because sometimes when you save the ANSYS file, if it is a complex geometry or complex meshing is required, it will be more than 300 GB sometimes. So it is very difficult to carry out without any hard disk. So this much amount of data. So that's why they provided an archive option. In archive options, you have the options to deselect the result file. So results will be there, but it will avoid, it will not carry the results file. So it is easy for the sending, or it is easy for to take it out for any presentation, because the file size is very small if you deselect the results and externally imported objects. So that's the way of saving it. That's what is called as archive. Then ANSYS Minerva, it's another option we are not going to discuss in this lecture. Then scripting, which we use it for automating, to record the operations whatever we are doing inside the ANSYS. And next, export report. You can use the report option to generate report, and this option you can export the reports. Okay, next one, view. So view is used for reset, to carry out the different views and reset your workspace and reset your window layout. This is the most commonly used options, because sometimes you will miss some of the condition. For example, if you close the unknowingly you closed the work in the graphics window, you can go to V and you can reset your workspace. It will be back to normal. And you can also use the reset window layout, so it will reset into the default window layout. Then toolbox, this is a toolbox, and it will be having toolbox customization options, and where you can disable some toolbox if you don't want it. So these options can be provided in toolbox customization. Then outline objects, when you click you can see the outline of the project data. Then these options, we don't use these options for unless otherwise you are interested in specifically you are doing some complicated project and you want to track all the proper processes, then you can use these options. Otherwise you don't use these options. And messages, progress, sidebar held, it will automatically pop up if there is any error, because if you click the message, it will open the message dialog box, message toolbox, but no messages are there, so that's why it is not listing. If there is any message, it will automatically pop out. Then you can also disable or enable the toolbars, show the connections, all these things are there. Then next is tools. In tools there is actually refresh project, update project. Refresh means suppose your project is there, you want to refresh the project, that means you want to refresh the data and everything, you can use the refresh project. Update project means you have gave the boundary conditions, engineering data, everything is there, you already completed the inputs for your analysis, and if you click on the update project, it will automatically solve it, and it will whatever the pre-processor things post-processor things you are created, it will update that also. So basically it is used to update, or you want to automatically solve whatever the projects available in project schematic, and you want to update all those things, you will use this update project. Otherwise you can go here and there is individual update is there, you can do that update. If you click this update project, it will update the entire thing. It is similar to this tool update project. Okay, then the next important thing, it is actually a blessing in ANSYS, because in ANSYS it is having units. So you can give in your own units, because most of the other softwares, if you go to Abacus, I'm not degrading Abacus, I'm not saying Abacus is Abacus is a bad software, it's not like that. It is also a good software, but one of the troubles which it creates, it's a lack of units. So in Abacus you must give you must know the units, and you must give the properties in consistent units, otherwise it will create a lot of problems. But in ANSYS they actually gave us the units, so you can give the results in particular units, the available units. Then extensions. Extensions means suppose you have created some extensions, you can use it. Otherwise some extensions created by the other people, that is available in ANSYS store through the customer portal, I think. So you can download those extensions, you can freely use, some of them are free, so you can use it in your analysis. Then jobs, it's actually deals with the solution process. You can create job monitor, and you can create the cloud solving process, all these things related to jobs. And help, it's usual help, it is provided for any software that is provided here. ANSYS workbench help, contacts help, installation help, licensing help, all these helps are also available. And there is something we want to discuss, that is on the lower left bottom side you can see job monitor. So it will show the how much job is completed and what is happening. All those things will be shown here. Next, DPS connection, show progress, show messages. So already there are 3 messages. So I actually completed some. I actually tried to import some geometry. It is not able to import the geometry, so plugin error happens. So these messages are there, and you can also, if you want, you can delete these messages. And that's all about the workbench interface. Next, we are going to discuss about the preprocessor things. Generally in finite element analysis there will be a preprocessor, solver and post-processor. The total process you can divide into 3 stages. First is the pre-processing stage, second is the solver stage, third is the post-processor stage. So in preprocessor you will give the engineering properties, you will create the geometry, you will divide the geometry into small finite elements, and you will give the boundary conditions where the load acts and where it is fixed. All those things you will apply in setup, or that is called as a from this engineering data to the setup, it is called as a preprocessor. And once you click the solution, it will solve the problem, that is solver. And after solution you will get a lot of numbers, so you need to convert that into in terms of graphs or contours. So for that purpose post processor is given, that is results provided as results in ANSYS. And we are going to discuss about engineering data, that is material properties. What are the material properties required to give for the analysis? So I'm just opening this engineering data, and you can see one of the advantage and at the same time some of the disadvantage is this one, because ANSYS automatically assign structural steel material for analysis. So that, which means already there is one material, that is structural steel, and if you don't change the material, or if you forget to change the material assignment, by default structural steel is assigned and your material will be structural steel. So you need to create your own material and you need to assign your material in the model stage. So otherwise structural steel being by default assigned to your analysis. Okay. And before starting to discuss about these things, we want to understand what are the quantities which require for the structural analysis. So for that I am actually going to my OneNote. So a structural analysis, which means suppose I will draw the stress strain diagram. 1 second. Sorry. Something happened. So we'll start with a stress strain diagram, because while explaining the stress strain diagram you will understand what are the properties required for your analysis. So I'm taking the line tool. So this is my y-axis and this is my x-axis. Okay, and this is supposed to be my Young's modulus line. Okay, so otherwise I will take another color, so it will be better. Okay, and this will be my failure curve. So this is stress and this is strain. This is my stress strain curve, and this stress strain curve, it is actually generated when we look into the tensile test, that is UTM. We'll take a universal tensile testing machine or universal testing machine, and if we do a tensile test you will get a load deformation curve, because we will give the load, we'll look for the deformation, again we will increase the load, we will look for the increased deformation, and we will plot the load deformation curve. But the problem is that whenever the specimen changes or it changes its shape, the load deformation also changes. So we want something which is purely depends upon the material, which is not changing with respect to the shape of the specimen. That's why we'll convert that into stress strain diagram. So the initial part, this is called as a linear part, or for an isotropic elastic material this is called as a linear part, linear region or elastic region, where when you release your load, what happens, it will back to its original position. That area is called as a linear area or elastic area, and the slope of this line is called as Young's modulus. What is the significance of this Young's modulus? Because if you got a stress, if you touch this line and if you draw it, you will get the strain. The equation is that stress is equal to Young's modulus into strain. This equation is similar to some other equation. It's a simple line equation. Y is equal to mx plus c. This equation is familiar. So where m is the slope and x is the x-intercept and y is the y-intercept and c is the constant. So if you remove this term, that is c, then y is equal to mx, it is similar to sigma equal to E epsilon. So E is the slope and strain is the x-intercept and sigma is the y-intercept. That means if he knows Young's modulus, you can calculate strain from stress. Okay, so we need Young's modulus to calculate the strain, or in other words the deformation per unit distance. You need Young's modulus. And similarly, if you pull something like this, suppose this is a box and you are pulling it, you are applying a force here, and this area, if you fix this face, obviously the length will be increasing, but the two things will happen. That is, first this direction the length will increase, but what about this direction? It will decrease its dimension. That is, the deformation, negative deformation will happen. How to calculate this negative deformation? That's why we need another elastic constant that is called as a Poisson's ratio. Poisson's ratio is required because Poisson's ratio is the it's a lateral strain by longitudinal strain. So if you incorporate, if you know the deformation or the strain in this direction, from Poisson's ratio you can calculate the deformation change in these two directions. So two things you required for analysis, for a elastic structural analysis. First thing, Young's modulus and Poisson's ratio. Generally it is called as, these elastic constants can be calculated from Young's modulus and shear modulus, Young's modulus and bulk modulus. So any two elastic constants is sufficient. That is a requirement. Either you must have a Young's modulus and bulk modulus, or Young's modulus and Poisson's ratio, or Poisson's ratio or bulk modulus, or Poisson's ratio or shear modulus. Any of these combinations, at least you need two elastic constants to find out the deformation or the stress. So that's why we must give these two for the elastic analysis. And if we back to our engineering analysis, the structural steel is there. Okay, we will keep it there. We are going to create a new material, and my material's name is steel. I'm going to create steel, my material. So a green question mark is there, which means there is no properties currently assigned to this material. It's just there a name only, there is no other properties. So we want to assign the properties. For that, I'm going to assign isotropic elasticity, because I am assuming my material is isotropic and elastic. So if I drag it there, the only two questions will be there, Young's modulus and Poisson's ratio. As I said, you only require two elastic properties. You can change this into shear modulus or bulk modulus or anything. Sorry. And I'm going to give 2E11 as my Young's modulus, because steel's Young's modulus is 2E11 and Poisson's ratio is 0.33. It's completed. Okay, this 2 is the steel, the question mark is it's gone, so it's perfect material. It is assigned to it is not assigned, it's created in the engineering data. If you want to assign it to your analysis, you must go to material model, that is model, the meshing area, and you can assign it. And in engineering data, you can see other things, that is there are different properties you can assign. This area which will show the different kinds of properties, and this area it will show the file menu, all those things. It's similar to the previous one. And one more interesting thing, it is having an engineering data sources. Engineering data sources, if you click there, you can see there are a lot of researches is going on the new materials and the old materials. All those research properties, researchers will generate some properties, and from those research, some of the research data are carried out by ANSYS, and they are ready-made or they are prepared for use for analysis. So that is called as engineering data sources. So if you click on general material, some of the materials are given by ANSYS. You can see FR4, copper alloy, grey cast iron. So these materials are given and its property already given. So if you go to this one, it will show the fatigue property where it is taken from. All these informations are given. Okay. Then some of them was not given, so you need to calculate or you need to go to the source where it is taken. All these things you must inquire. But a lot of materials are given here. So if you go to explicit material, it is just like the static structural analysis. Some other types of analysis is also there. Dynamic analysis. One of the kind is explicit dynamics. If you click on explicit, you will get explicit materials. So this is actually explicit materials. I don't know, it takes some times to load. 1 second. Yeah, it's loaded. So if you click here, you can see some of the materials, explicit materials, and geomechanical materials. Some of the materials are given. So in geomechanical material, the material properties will be different, and the material properties purely depends upon what kind of analysis you are going to do. And suppose you are going to do a CFD analysis, the fluid properties will be there. If you are doing a dynamic analysis, some other things like a fracture, all those things, details are required if you are interested in crack or such things. So what are all the material data required, it is purely depends upon the type of analysis which you are going to use. Okay, then next for engineering data, I am stopping this because when we do the static analysis and transient analysis, we will discuss more about this engineering data. So we'll come back to this engineering data in later in these classes. Thank you.